We're trying to generalise a formula to find the area of a regular hexagon with sides n. To do that, we're going to split it into 6 equilateral triangles, which I've done already, and then we just need to find the height of our equilateral triangle in terms of n, so that we can work out its area using a half base times height. So if I take that right angled triangle, I know this side, the hypotenuse, is n. I know this base is n over 2 because it is exactly half of my equilateral triangle. So all I need to work out is x, my height. By Pythagoras, I know that x squared is n squared minus n over 2 squared. So I know that x squared is n squared minus n squared over 4. So n squared is like a whole, n squared over 4 is a quarter. So actually we can say x squared is 3/4 n squared. So then the square root of that, well, the square root of 3 is root 3. The square root of n squared is n. The square root of 4 is 2. So now I need to work out the area of one of my equilateral triangles and times it by 6. So the area of one triangle will be root 3n over 2 times my base, n, and then times a half. So one triangle is root 3 n squared over 4. The whole hexagon is 6 of these triangles. So 6 of them, 6 times root 3 n squared over 4. Then we can do a little bit of cancelling. So the general formula for the area of any regular hexagon with sides n is 3 root 3 n squared over 2. So I now want to find the area of a regular n-sided octagon. To do that, we are going to put this octagon inside of a square. The reason this works is I can find the area of the whole square and take away these 4 right-angled triangles that I have in the corner. So the other part of information I need is to know what this length is along here, along the side of my right-angled triangle. I already know the length of my side of octagon because I called it n. So let me just move that out of the way, and then we can figure out this right-angled triangle. To do that, we are going to use Pythagoras. So this hypotenuse here is n, because of course it's part of my octagon over there. So this means that x squared plus x squared equals n squared. So 2x squared is n squared. So x squared is n squared over 2. So x is the square root of that. So the square root of n squared is n over root 2. Then I'm going to rationalise my denominator by timesing it by root 2 over root 2. So x is root 2n over 2. Once I've gotten that far, most of the battle is won, so I just need to find the area of the square. So the area of the square will be n plus my 2 x's, so like here, here, and n is one side of my square. So n plus 2 root 2 n over 2, to use this x over here, squared is the area of the whole big square. So now I can do some cancelling like this, and actually I'm not going to bother multiplying it out because we're going to do some sneaky factorising later that will make our lives easier. So I'm going to leave it as n plus root 2n squared. So I also need the area of my triangles, and then I've got 4 of them to take away. So the length x is here. So the area of a triangle is base times height divided by 2. So that'll be x squared divided by 2. So that's root 2n over 2 squared times a half, or divided by 2. So that'll give me, on top, I'm going to have 2n squared over 4 times a half. So these will cancel out. But then actually I'm going to want 4 of these triangles, so my denominator will also cancel. So my area of my octagon, the area of my final octagon, which is going to be like a terrible drawing now, the area of my final octagon will be n plus root 2n squared minus 4 lots of this one, so n squared. So maybe you can see why I chose to leave that not multiplied out, because actually I can take a factor of n inside here. So I can take it out as n 1 plus root 2 squared minus n squared. So then I can square this separately and take it outside. So I can say n squared 1 plus root 2 squared minus n squared. Then this we're going to have to take to a new page. Okay, so from here we are going to take n squared out as a factor. So I can say 1 plus root 2 squared minus 1. So the whole thing's all coming together. Then 1 plus root 2 squared, I can expand. So this becomes 1 times 1, 1. Root 2 times 1 and root 2 times 1, so 2 root 2. Root 2 times itself, so plus 2, minus 1. So this becomes n squared, 2 plus 2 root 2. So I can take another factor of 2 out. 2n squared, 1 plus root 2 as my final answer.